Hello, welcome to our talk on Entity Framework. Thank you for coming here, especially because you had to walk a lot to get here. I know, I had to do it myself. My name is Diego. I work as a program manager on the EF team, and this is Smith.
I'm Smith Patel. I'm developer on EF core team. I mainly work in query compiler and Cosmos DB provider.
Yeah, we have a tradition that we are starting today that we are jumping directly into the demos. We are not going to talk a lot about roadmap or things like that until the end of the presentation. So let's switch to the other machine. So our demos are going to be about EF Core 2.2 features. We are going to talk a little bit about EF Core 2.1 as well, but we wanted to show you the new features because we really want feedback on all these new things that we are building. We need it because we need to release a final version by the end of this year, and we need all the process to complete to do that. And our demos are also console applications that target .NET Core. They are available in source code in GitHub, so we're going to show you the link for that. And we are introducing some code to show you the logs of all the SQL queries that we are producing so that you can visualize that. You want to start?
Yeah. So our first demo is about a feature we added in 2.2, which is own collection. So in 2.0, we added concept of own entities. So own entities are similar to how entity types is, but it has a stricter relationship. So there is an owner and owned entity. So owned entity cannot exist without the owner. And so in normal scenario, yes, it is similar to like how another entity type is. But in terms of like saving changes or querying, all those things, own entity it has to be with owner only. It cannot exist on itself. Even you can't create a own entity on itself without using a reference navigation to that. So as a recap, first we are going to look at own entities, which was for reference navigation in 2.0. So here we have customer entity, which has home address and work address. So in address class, we have just string properties. There is no ID property or any primary key property. So own entities is kind of a superset of what we had in EF6 as a complex type. So own entities are like, yeah, bunch of just values, and you can use it in entity type, and it will automatically derive primary key and save it accordingly. So in order to define own reference navigation, basically the API was owns1. So we declared both home address and work address as own entity. So if we build model, we will just build a model from this, create a database, and save some data in it. So if we run this demo, build errors. No, there are no build errors, hopefully. Something happened. Just a moment. There is a build error.
I can fill in while you fix the issue. So this concept of ownership is important to us because we wanted a way to express in the model that stronger relationship between entities. And in relational, if your database, the database that you are targeting is relational, the only value that you're going to get is basically having that restriction that you cannot manipulate own entities without the owner. But when we start targeting document databases and non-relational databases, that is actually going to be used to make another decision, which is when you're using a document-oriented database, you usually store things that are related in a single document. So we are using that to pivot and decide, okay, an entity, let's say the customer, and all its addresses are going to be stored in a single document. And that is something that is going to be part of the way you model in EF going forward, and you are going to be able to use it independently of what database you are using, but it's going to have different consequences.
So we got our demo working. I guess Visual Studio needed a restart only.
Okay.
So for own reference navigation, basically the create table script we generated has home address and work address and all their property in the single table with customers. So this is the feature table splitting. Complex type were also mapped this way only. So for reference navigation of own entity, it goes to the same table. So in this case, So it is working fine, and like we got 2 addresses. Suppose we have a list of addresses and you have like n addresses, but you don't know the numbers. You can't have a reference navigation for that. So we need collection navigation of own entities also. So that is the feature we have added in 2.2. So if we modify the demo to use that, so let's remove this navigations and add a collection navigation. So own collections are good. They map to a different table. So currently we have to define an ID property as a primary key. It is supposed to use a composite key. It is not being done by convention, but before RTM we are planning to fix it.
Yeah, that's an interesting concept in own types. They borrow the key from the owner as well, so that the way they get stored is always a composite key in the case of collections.
So in order to define a collection as a own entity, the API is owns many. And now we just have to change the data addition part. So if we delete this, okay. And if we run the demo again, so for relational database for own collection, basically we created a customer table and address table, which is different. Since each customer can have multiple addresses, it cannot be stored in the same table in the same row, because there can be multiple and we don't want to duplicate data for customer part. Therefore, they are mapped to 2 different table, and address has a foreign key to customer table. So for relational databases, this is quite similar to how one-to-many is. It just on the database side, it is same as how collection navigation is, except on the client side, since it's owned, it has to exist with owner only. It would be auto-included, and there are all other behaviors around it, which is on client side only. It is interesting in the sense like, so the reason we added this, because for non-relational database, it could be a quite different thing. Basically, it goes to like aggregate concept of DDD. So an owner with all the own entities inside is a part of aggregate. So it is always work together. You always load it from database at the same time, which auto include does right now. And you save concurrency control would be on the owner level because you save it. So main reason we added this feature in 2.2 is Cosmos DB provider, which is our first non-relational provider we are working on. So for a document DB provider like that, which use JSON document to store the data, own entity goes as embedded resources or a nested structure inside the owner. So whole aggregate would be a single document which would have own entities and inside nested. And since a JSON document could have objects and arrays both inside nested, so we had to introduce own collection.
Yeah. So one way to think about this feature is about when to use it is, for instance, a customer address is a good example, because normally when you load the customer and you want to modify the data of the customer, it's pretty handy to have the addresses loaded with it to there. But for instance, don't use it with customer and orders, because it would be very strange. I mean, the scenarios in which you want to load all the orders for a customer is actually pretty small. You probably want to be able to load the order by itself and work with it. So the next, did we forget anything about this one?
No.
Okay. So the next demo is going to be about a new feature that we're introducing. It's one of the big features in 2.2 that is spatial support. So there are databases out there. You may be already familiar. You may be one of the people that have been asking for this feature that support rich spatial features, spatial. So you can have a point or a polygon or a surface or a line that can be represent like something in the planet Earth, or it can be just a geometrical object. And those databases allow you to compute functions on them, to do queries that evaluate predicates that are based on functions on them. You can check, for instance, if this point belongs in this polygon or it doesn't, or what is the distance between these 2 points. And databases like SQL Server and Postgres and Oracle have that capability, and people were asking for us to have support for that in EF Core. The other part of the feedback that we got that was interesting is that they wanted to have like provider agnostic types that they could use to do this work. So SQL Server has its own types that happen to be, by accident of history, CLR types. They are .NET types, but they are for .NET framework that represent geography and geometry. But many customers that talk to us said, okay, well, that could be sufficient in the short term, but in the long term, we really want database agnostic types in .NET that we can use. So we went around looking for if there is any existing library that we can use for that, and we actually found that the PostgreSQL provider for .NET Core and .NET, NPG SQL, had already adopted such library. There is a library that's called Net Topology Suite, or NTS for short, that implements the standards for geometry and geography, and it's already available. It works in .NET Core and in .NET Framework, and there is this provider out there that already implemented a version of this feature or a subset of this feature. So we decided to try it, and we came up with this feature that we have in preview right now.
So in this demo, basically we are persisting measurement entity, which is basically at a given time and given location, what is the temperature. So location here is as a type point, which is type coming from Net Topology Suite. So in order to persist the type of location, which is point here, we need another package which enables spatial extension, which is Microsoft Entity Framework Core.SQL Server.Net Topology Suite. So for packages we produce, we adopted provider.net topology suite as the naming convention.
Yeah, this is a new type of extension for EF Core. It's basically a type mapper extension for the provider. We expect to release more in the future. Every time there is a new type that is interesting that you want to map, or we expect people to be able to extend the provider adding their own type mappings.
So in order to use Net Topology Suite in your DB context, basically in your normal use SQL Server syntax, you pass the second argument and configure SQL option.use Net Topology Suite. This will enable all the type mapping and function mapping coming from Net Topology Suite package. So then we are basically going to create a database, save some data, and run a query. So if we run this demo, so this is our create table script. So basically we have mapped location to geometry column in database, and we have saved data in that. So our saved data was basically like we provided point, and which got converted to geometry type while saving the data. Next we will run a query. So in our query, basically we have current location 0, 0. We are going to find all the measurements which are less than 2.5 distance from current location and sort them decreasing by the distance. So if we run that query, so the select expression we generated for the link query is using stDistance function in where and order by, which is what distance from point.distance would translate to on SQL Server. And as we can see, there are results in decreasing order I listed correctly. So we currently, that's what Net Topology Suite package brought. It's like type mapping to map those types, and also some of the functions and members defined on those types, which can be converted to SQL Server specific functions on the server side in the link query. And with that, a lot of queries can be translated to server side also instead of doing client evaluation.
Also, what about SQLite?
So the main reason to use NTS was to make a provider agnostic. So here we use SQL Server. So suppose we want to use SQLite. So for SQLite, the package is like following same naming pattern, SQLite.net topology suite. All you need to do is like instead of doing use SQL Server, you need to call use SQLite as you normally do and add the same thing, SQLite option.use net topology suite. So now our DB context is going to target SQLite provider. There is no other change. We are already referencing the package, so we don't need to change anything on CS approach there. So for SQLite, basically it is enabled by using Spatialite module for SQLite 3. So the table we created is, so measurement table is general with, and the geometry column is added separately. This is spatial syntax, how Spatialite works. So we created and persisted the data. And if we go forward and run the query, so this is the query we generated for same link. Here we are using distance function, which is the function comes from Spatialite, which is different from what SQL Server provided. So each provider specific net topology suite package brings in the type mapping relevant to that provider and the function mapping relevant to that provider.
Yeah, so to recap, these net topology suite types like point we are using in this demo, can be used now across SQL Server, SQLite, Postgres provider, and also the in-memory provider. You can use it directly without configuring anything. Just put it in the properties of your entities. So the next feature we're going to show is something that is going to help you if you have a very large application. Have you ever had a large application and you look at your SQL logs and found some issues trying to identify which link queries the SQL is coming from? I had that problem. So if you are trying to investigate a performance issue or some other kind of issue with SQL, you usually look at the logs, and then if you have a large application, it's really hard. This feature is very simple, but it's the ability to identify a link query with a tag. So it's just a new operator that you add to your link queries.
So for the feature of query tagging, what we have added is we have added a new API called with tag, which can be applied to any iQueryable. So you can put in your link query wherever there is like iQueryable, so you can compose a word through different function and stuff. So the syntax is with tag takes a string. So when this link query is going to be compiled and the select expression is generated, we would, so in this case, this is the select expression we generated, and as you can see, we have added a comment with EF core prefix, and it contains the whatever string argument you have provided as is. You can use with tag with different argument multiple times, and all of them would be combined in the comment. As I said, it can be put anywhere, so composability is also not an issue. And if EF core is going to run multiple SQL against database for same link query, it would be having comment in like each of those SQL. So this is really useful to find out from which link query what was the select expression generated.
Okay, cool. So the next feature we are going to talk about is our Cosmos DB provider. That is one of the large features that we encourage you to give us feedback on. We have been talking to customers almost from the beginning of EF Core about the fact that we wanted to support non-relational databases, and we did some experimentation with that. We had a prototype of an Azure table storage provider. We had a prototype of a Redis provider, but we always knew that the really great fit in the non-relational world was going to be document databases. And building a provider for Cosmos DB apparently makes sense to a lot of our customers. We have been talking to people that say, okay, I love Cosmos DB and I love EF Core, but I'm a .NET developer. I prefer to use this programming model. I prefer to use this API to talk to Cosmos DB. So if you enable it for me, I have more projects in which I'm going to use Cosmos DB. And we have been working, we had a prototype for a year, more or less. But we threw away that code, and now we are working on the real code base for the provider. It's still limited, and it has known issues. But we believe that it's ready for you to play with it.
So for Cosmos DB, basically we are taking here blog and post model. So blog has list of post. In order to configure your derived DB context, which is blogging context here, to use Cosmos DB, basically the API is use Cosmos SQL. That API comes from the package, so which is a new package for Cosmos provider, which is Microsoft Entity Framework Core.cosmos.sql. So in Cosmos DB, the current package is targeting SQL API. So the use Cosmos SQL takes argument API endpoints, authentication key, and database. So in particular case, this API endpoints and auth key are for Azure Cosmos DB emulator, which is a Cosmos DB emulator for local development work they provide. So this is the configuration all you need for to target a Cosmos DB rather than another provider. So in the demo, first let's create the database.
Do you need to restart the emulator maybe?
No, emulator is working.
I can fill in until you fix it.
Yeah.
The last time we presented with this emulator, we had an issue with the fact that it doesn't work if you don't have a network connection, but I hope that's not the case now.
No.
So one piece of feedback that we received when we started showing the prototype is that people realized that by default we were mapping each entity type basically to its own collection in Cosmos DB. And people called our attention on the fact that that could cause their Cosmos DB bill to become very high. Because at least with the pricing model that Cosmos DB supported at that point, it supports basically, well, you can have as many collections as you want, but each collection you are going to have to pay for a minimum number of a minimum amount of throughput and storage. So if you have lots of underutilized collections, then your bill is unnecessarily big. Now they support a different pricing model, and the pricing model is always evolving, and also the price is always evolving. But one of the things that we wanted to add is the ability to just map all the entities from the model, if you want, to a single collection. In this version of the preview bits, we actually do that by default, and there is no way to do any other kind of mapping. But the idea that we have for RTM is to support mapping everything to a single collection, mapping as you want, basically to separate collections, and also controlling the name and the configuration of each individual collection in the database.
Seems like Visual Studio does not want to run the app.
What can I talk about now? I can switch to the other machine and talk about the roadmap while you fix this.
Yeah.
Okay. So to recap a little bit on EF Core 2.1, this is something that we released in May. And the main features that we had there are value conversions. Value conversions is about having a transformation happen whenever we materialize an object for a property. When we read the value from the column and we need to create the value for the property, we can execute your own code, or we have some built-in transformations that we can do. And vice versa, when you need to persist the value from a property into a column, we can do the opposite transformation. So this works for storing like a JSON object in a string column, for instance. It works for converting enums to strings if you want to store them that way. It also enables us to support types that are not natively supported by the database. For instance, the SQL Server doesn't support unsigned integers. But now you can have them in your model because we'll do the conversion automatically for you. Query types is also a new feature that introduces in the model the ability to have objects defined that are like entities but without keys. So they don't have primary keys and they are read-only. So they are ideal to be mapped against results from store procedures or results from views, basically. And then we have data seeding, that is this ability to declaratively put in the model, okay, this is my initial data for the database, and when you are using migrations, migrations can compute the insert, update, and delete operations necessary to reflect that into the database. Group by translation, that is kind of a given that we had to have that, and actually Smith implemented a lot of it. And lazy loading that many customers wanted, and while we were doing lazy loading, we wanted to create this feature that actually provides a lot of value, because I don't like lazy loading that much, but that is the ability to have parameters in your entity constructors. So you no longer need to have a parameterless constructor. You can inject the values of the properties through the parameter, and you can also inject services into the entity. Now, for end of this year, we are planning to release EF Core 2.2. The main features are the ones that we talk about. There are going to be like hundreds of bug fixes as well, but these are the main things. And did I say already that we wanted your feedback on this? I think I did. Well, the Cosmos DB provider in particular is the biggest and riskier thing that we are working on. And it's going to depend on the feedback that we get, whether we feel like it's ready to be released by the time we release 2.2. The 2.2 release is going to ship at the same time that .NET Core 2.2 ships and ASP.NET Core 2.2 ships. So from our perspective, it's date-driven. It's a date-driven release. We already promised that it's going to be ready for the end of the year, but if the Cosmos DB provider is not completely done, we are going to have to postpone it a little bit. The Cosmos DB provider, not the 2.2 release. And for next year, we are working again on a much bigger release that is going to be 3.0. One of the main things that we are doing that actually Smith is working on is a redesign of our link implementation to make it more robust and to also support translating more link queries into SQL. Aggregate behaviors is basically extending something that we already have a little bit of. Currently, when you define own types in the model, you no longer need to include in your queries because own types get auto-included in the results. So we want to extend that also to do things like versioning or concurrency control just on the root of or the owner, so that whenever you save, you don't need to put concurrency tokens as properties in the own types. You just put it in the owner, and we automatically control concurrency based on that. We want to also do cascade deletes control based on this shape of the aggregate. Aggregate, if it's not clear, I think that Smith mentioned that it's a concept from domain-driven design, that to just give a super simplified definition of what it is just a group of entities that you want to work with always together in your use cases. So you want to query for them together, and you want to save them together, you want to modify them together. Another thing that is coming at the same time that .NET Core 3.0, EF Core 3.0 is a new version of C# and a new version of the languages that are going to have some interesting capabilities. And there are two things that actually may have an impact on EF Core. So the C# team is finally going to standardize on an interface to represent asynchronous collections and also asynchronous disposables. And right now, EF Core to implement async is using a non-standard definition of this interface that is coming from the Microsoft Interactive Extensions. But finally, we're going to have one that is integrated with the language. You are going to be able to do for each async without invoking an extension method. You are going to be able to create async collections also using an iterator pattern with yield async. So we want to replace the one that we are using with that one. Another feature that is coming is nullable reference types, and we actually don't care about nullable reference types. We care about the non-nullable reference types that are coming with them. Imagine that you have a property that is of a non-nullable string. If we know that it's not nullable, then we can make the column on the database also not nullable. And when we produce predicates for that column, we can generate simpler SQL automatically. Also, public code first conventions. Right now, if you want to manipulate how the code first pipeline works and what conventions get run and how they affect the model, you need to tap into internal code. We have these public internal APIs that they are public, but they are defined in internal namespaces that we recommend people to only use at their own risk because we plan to change them on every release. But we want to have a public way of doing this. We already had it in EF6, and we want to have it on EF Core now. Property bug entities. This is another interesting feature that enables mapping to .NET classes that instead of having just normal properties in .NET, they have an indexer property. For instance, an iDictionary of string to object could be used as an entity type, and we can store the values inside the dictionary as elements in the dictionary. And it also enables having different types from the conceptual model, different entity types from EF Core mapped to the same CLR type, basically. In the case of a dictionary of string to object, that could be one. And that is going to be a stepping stone for us to support many-to-many without an entity in the middle of the relationship, because that entity in the middle is going to be materialized as just a property bug. So you don't need to define it in your model. It also, is there anyone here that uses F#? No F#? Well, F# has this feature that is awesome, that is type providers, and there is a flavor of type providers that are called erasing type providers, and they could use property bugs as well at runtime. Reverse engineering of use, this is something that we wanted to do for 2.2. Now that we have query types that are entities without keys, those are perfect to map to views, and we wanted to have them generated automatically when you reverse engineer a database, but we are not going to do it for 2.2. And then a way to tell migrations not to mess with a specific object in the database. That's something that we plan to do. There are many other features that we hear customers want like many-to-many, TPT, and store procedure support that we want to do. We don't know exactly whether they are going to fit in 3.0, they are going to fit in some other release in 2019, or when. So that's why they are not in this list. But we hear that they are important, and they are especially important for customers that are using EF6. So the other thing that we are doing next year is actually we are going to ship a version of EF6 that runs on .NET Core. And the reason we are doing this, it can be a little bit confusing, but it's because there is a lot of existing code that targets .NET Framework, and the whole .NET organization is working on trying to make it super easy for existing applications to just move to .NET Core and to not use .NET Framework anymore. So the same way we are making it possible to do WinForm applications on .NET Core and WPF applications in .NET Core, we are going to make it possible for you to just recompile your applications using EF6 and run them on .NET Core. That is not going to change the status of the project. It's basically still active, but we are not investing a lot on it. We are not creating new features. We are recommending that people that can afford it move to EF Core, and people that are creating new applications use EF Core. But it should be much easier to move an existing code base to .NET Core with this. And it's going to run everywhere where .NET Core runs, basically. Not Xamarin, but Windows, Linux, and Mac. And there are going to be limitations. Like, for instance, we don't expect, we are talking to the SQL Server team, but we depend on the SQL types assembly that they ship that contains all the spatial types and hierarchy ID. And unless they ship a version for .NET Core, we are not going to be able to support that on .NET Core, the spatial types in particular. And if you have an application that uses Oracle or uses some other provider, you are going to have to wait also for them to ship a version of their provider that targets .NET Core. It's not going to be automatic. And finally, we don't know, but the designer may also have some limitations, because the current EF designer in Visual Studio assumes that the target of the project is .NET Framework, so we may need to make some adjustments. Is it working?
We had a backup.
Okay.
So looks like using nightly package and stuff, bleeding edge technology actually made us bleed. So we did not get that to work, that app on there. I guess that's also described, it is not production use ready. It is provider for experimentation. So you can try it out and give us a feedback. So as we were saying, we have a blogging context with blog and post here. So we are going to create database first. So if we run the app, this works out. So we created the database. So this is Azure Cosmos DB's data explorer for emulator. So here we have database name EF Core demo created with Unicorn as a collection. So as Diego mentioned, that because of the pricing model, we decided to create one collection. Currently it's called Unicorn because it's kind of a placeholder. We were developing it. We did not come up with a good name, so we just use Unicorn because Unicorn is EF Core's mascot. We intend to name it to derived DB context type or make it configurable to user, so you can map it. Also on the pricing model, like user will have ability to map particular entity type go to one collection and other collection based on how different entity types going to be utilized and what is the throughput needed for that. So next in the demo, since we have database created, we will add some data. So we have first blog ADO.NET with 2 posts in it and 2 other blocks. So if we save this data to database using save changes. So we saved 5 records to Cosmos DB. So if we look inside our collection, so we have 5 documents created. Since all the entities maps to one single collection, we also introduce a discriminator column to identify what is the kind of entity for that inside that collection. So blog will have discriminator of value blog, and post will have discriminator as set as post. So this is what is configurable to user side, and that is how user can specify, okay, this entity will go to certain collection and it will use different kind of discriminator or whatever they want to configure, and you can have your database mapped as you want them on Cosmos side, and EF Core will just use that model. So now we have inserted some data. We will iterate over all the blocks. So since we are targeting SQL API of Cosmos DB, we are using SQL here to get results from database. So SQL we generated here has a where predicate discriminator. That is because we are mapping everything to one collection. We also need to use the discriminator while querying, so we don't get data for other entity types when we are querying one entity types. And here we got result of 3 blocks. Next in the demo, we are going to load blog which is named ADO.NET and load post collection navigation for it. So to when querying for blog whose name is ADO.NET, we generated where predicate with seed name equal to ADO.NET. So currently in our query provider, we have almost all binary, ternary operator, everything getting translated to server side. There are still a lot of functionality missing on query provider in that way. So all the functions on server side supported, which have equivalent counterpart in C# or LINQ, we are not translating right now. Before we RTM, we plan to improve the query provider as much as so that we can process most of the query on server side and fetch lesser amount of data. We also plan to optimize out how the joins are performed, because Cosmos DB does not support join between different collections and different documents. And for the loading the post part, we are using blog ID with the parameter here. So we also have all normal query caching functionality of EF core also preserved there. So we retrieve 2 posts here. If we suppose like next thing is like, yeah, for post 0 of blog 1, let's modify its content to content removed and save that to database. So if we run that, okay, we saved 1 record to Cosmos DB. If we now go to emulator and refresh it, so this is the post 1 for blog 1 and content is now content removed. So currently in the provider has been implemented in a way that you can create database, you can insert data, you can query the data and make modification to that data. So end to end it has almost working functionality. So it is ready for use for, you can use it for testing and experimenting and figure out what other features you would like in that before you actually decide to use for production. Your feedback would be useful for us to prioritize things and determine how good the quality of provider is for RTM release. This is using nightly builds, therefore we were having some issues. So nightly build, every sync and asynchronous and synchronous both pipeline are running file. The one package which is previewed to on NuGet, it has DDL and DML, basically ensure created, ensure deleted and save changes asynchronous only and query synchronous only. That is because we were using Cosmos DB's SDK to access the data and they did not provide synchronous APIs for those tasks and did not provide asynchronous for query. But we have removed that restriction in our nightly build, and in next preview version of package it would be gone. So you can use it seamlessly how you use EF core in any other app.
Yeah. One limitation that we still have even in the nightly builds is that we are not doing this trick that I described before about storing the own types inside the same document. That's something that we really want to have for RTM, but we don't have it implemented yet. Another thing that we want to learn about, besides the difficulties and any limitations in the current bits, is what our equivalent of migration story is going to be for Cosmos DB. Cosmos DB, as you know, is a schemaless, but your application is usually not schemaless. You have objects that are strongly typed in general, and they have a shape, and whenever the application evolves, then there is going to be data missing in the database. Anything that you store with one version of the model is just not going to exist when you try to retrieve it with the new version of the model. So we need to learn how customers are doing that, and based on that, if there is any value that we can bring to the table by implementing a feature either to automatically update the existing database that is already there, or maybe even deciding what default values to use when the data is not there. Final message is basically, did I ask for feedback before? Well, we do need the feedback, so I'm asking again. Those are the names of the packages that you can try. The main 2 things that we showed today, the Net Topology Suite extension for the SQL provider, and Cosmos DB SQL is the name of the package for the Cosmos DB provider. whenever we make announcements, we usually make them using our Twitter account, EFMagicUnicorns, and we also use the .NET blog and our GitHub account, where you can file all the issues and all the feedback that I was asking for before, is in that GitHub repository. And this is the address for the demos. If you want to get them, it's also GitHub. And thank you for coming here. We want to thank you and thank all the people that are giving us feedback all the time. Did I say the word feedback again? So we are having a great ride being an open source project in .NET and working with customers and listening to them and trying to improve our products. So thank you for coming here.